Good morning, good afternoon, or good evening, depending on where you are watching and listening to us. This is the webinar marking the launch of the CRISPS project, a project funded by the High Volume Transport Program from the British government. My name is Susana Zamataro. I'm the Director General of the International Road Federation, and I'll be the moderator for the webinar today. Before we get started, let me just remind you some housekeeping rules. First of all of you, the participants, are muted by default. We kindly ask you to use the question and answer function to put forward your questions, and use the chat if you want to make comments during the presentations. But please make sure that your questions are short, possibly indicate exactly to which of the speaker you would like to ask your question, and use the question and answer function, because it will be a lot easier for us. It will be impossible for us to find your questions through the chat. So please do that. We have a number of presentations, but we'll try to keep them short so that we make sure that we have a bit of time at the end of all the presentations for some discussion and question and answers. If you're using Twitter or LinkedIn, please the hashtag CRISPS project. This webinar is being recorded, and both the slides and the recordings will be made available to you. Without further ado, because the time is pretty limited, we have scheduled 60 minutes for this webinar. Let me introduce you the speakers of this morning. Dr. Michael Borrow from the University of Birmingham, Dr. Ters Henning from the University of Auckland, Dr. Gurmel Gatahora from the University of Birmingham, myself from the International Road Federation, Professor Ratnasamy Munyandi from the University in Malaysia, and Dr. Bernard Obika, IMC High Volume Transport Program. Welcome, and thanks to all the speakers as well. A quick run through the agenda that we have for you for this webinar today. I will immediately pass the floor in a few seconds to Professor Michael Borrow for a quick opening and introductory remarks. Bernard Obika will introduce us the HVT program. We will get into a full overview of the CRISPS project, and then the other speakers will dive you into data deterioration modeling, the field trials and implementation. I will tell you a few words quickly on dissemination and outreach activities for this project, and then we'll get into the question and answers section. Without further ado, I'd like to pass the floor now to Professor Michael Borrow to give his introductory remarks. Michael, the floor is yours.
Thank you, Susanna. Good morning, everybody, or good evening, indeed, or good afternoon. This is the first in 8 of these webinars, which we'll have over the next 18 months, which will be outlining the CRISPS project and the progress that we've made towards achieving the CRISPS aims and objectives. It's with much gratitude that we thank the UK government through the Foreign and Commonwealth Development Office for funding the programme, and particularly we're very grateful to IMC Worldwide, and particularly we're very pleased to have with us Dr. Bernard Obika, who is leading the HVT programme. So welcome, and we look forward to engaging with all of you throughout the next 18 months. Bernard, over to you.
Thank you very much, Michael. If I can just sort of get to share my screen, and that will get... Okay, can you all see my screen?
Yes, that's perfect.
Okay, thank you. Good morning, good afternoon, and good evening, everyone. Isn't it wonderful that these days we have people from across the world and we can engage in such a meaningful way? If there was anything positive about the coronavirus, perhaps this is it. We can speak much more to each other and from various parts of the world. So my part is really to introduce you to the High Volume Applied Research Program for the low-income countries of South Asia and Africa. So the High Volume Transport Applied Research Programme is put in place by the UK government through the Foreign and Commonwealth Development Office and hosted at the IMC worldwide under the programme HVT. It's there to update vital transport research that reduces poverty and develops economies. By strengthening the evidence base that will support increased access to transport, more affordable transport routes, safer, low carbon and inclusive transport in low-income countries of Africa and South Asia. So what are we really talking about? We see huge impact on our economies across many low-income countries, ranging from 2 to 5% of cost and GDPs, for example, due to congestion. The big elephant in the room, climate change. Transport accounts for approximately 1/4 of the greenhouse gas emissions. We need to do something about that and make sure it's incorporated in the nationally determined contributions to climate change mitigation. Road safety, we see 1.3 million people who die every year, through road accidents, and to contributing to the global effort on road safeties. And of course, the pollution we see that it's causing so much havoc to communities around the world. And so that is really what the HVT program is about. How does that fit in the context of the global development, sustainable development goals? I read from a statement in the SDGs that says sustainable transport systems, along with universal access to affordable, reliable, sustainable and modern energy services, quality and resilient infrastructure, and all the policies that increase productive capacities will build strong economic foundations for all countries. So transport, it's certainly a key part of the SDGs and cuts across a number of other SDG targets. So how does the high volume transport work? The program is divided into 2 parts. In part 1, we subdivided our effort into 4 major themes. The first theme being long distance strategic road and rail transport. Urban transport has been the second theme. Low carbon transport, the third theme. And the 4th theme included such issues as gender, the vulnerable groups, inclusion. And within that sort of last group, we included also road safety. So we engaged with a number of fairly major research organizations to carry out a state of knowledge review, where we are, what are the real current issues affecting us, what are the barriers in low-income countries. This resulted in fairly extensive, what I still think is probably arguably the most comprehensive treatise, up-to-date treatise on what we know about transport in low-income countries. These were published in the Sustainability Journal, and there is a book that is based on those publications and it will shortly be published. In parallel with carrying out those state of knowledge reviews, we also undertook extensive knowledge management and capacity building work in parallel. So as we move into part 2 of the high volume transport program, we identified the SOK studies allowed us to identify the priority areas to focus our research efforts in. We narrowed this into 6 key priorities. That is on policy and regulation, including engineering. For example, the topic, the CRISPS, falls under this particular category, the topic we're about to talk about. Climate change mitigation and adaptation, a key focus for us. Inclusion, gender and road safety remained a priority area. Technology and the innovation, including, for example, decision support systems, such as HDM4, which many of you will be cognizant with, remained a priority for us. And of course, we have to address fragile and conflict affected states, and underpinning all of this issues, of course, is the issue of research uptake and capacity building, without which we will not see the impact of much of the work that we do. So,
1 minute, Bernard.
thank you. As we go through, just to highlight some of the activities that the HVT is undertaking at the moment, so we have 13 major research projects ongoing in various aspects of the priority areas I've mentioned. We have also responded to the COVID-19 pandemic with up to 21 response and recovery initiatives. And of course, we continue to work on various aspects of seeing impact of what we do on the ground. Why are we doing the research on road surfacing, the CRISPS program? Road transport and roads remain the predominant mode for low-income countries, often typically exceeding 3% GDP expenditure on roads. A large percentage of that cost is on the road pavement surfacing and materials. We see many examples of poor, inefficient practice. Who are the drivers for this poor and inefficient practice? Those are questions that we need to ask. Many cases I see thick, needless asphalt put into inefficient systems, road networks. Climate change and resilience adaptation is a key aspect of the road surfacing, and other issues I'm sure will be highlighted during this webinar. So we support policymakers, central governments, the private sector, practitioners, and the civil society in making impact and changing the transport systems. That is what HVT is there for. So follow us. The transportlinks.com is a website, and this presentation will be made available to you. So thank you very much, and I hope you enjoy the webinar. Thank you, Susanna.
Thank you, Bernard. Okay, thank you very much, Bernard. Thank you, Susanna. So, Bernard, that was a very nice introduction to the program and also to our project, really. But just to reiterate a little bit of what you said in terms of the project itself and in terms of what we're aiming and trying to achieve. As Bernard mentioned, there was a large study that carried out over a year, which looked at what should be the research in phase 2 of the research program. And our project, the CRISPS project, addresses one of the research questions which came out of the phase 1. And that question is, how can new ways of designing and building roads using new standards and marginal materials deliver low maintenance, resilient roads economically? So it's very much addressing the issue that Bernard says, is that in many cases we see roads are over-designed, in many cases we see they're under-designed. And certainly in the context we're talking of, roads are often not maintained. But before I go on and talk a little bit about the project, give you an overview, just to introduce you to the project partners. So we have ourselves at the University of Birmingham, and at Birmingham we have 3 institutions and schools involved in the research. That's ourselves, Dr. Couture and myself at the School of Civil Engineering. We have the International Development Department, and we have the Department of Physics and Astronomy. Project partner from Auckland, New Zealand, Dr. Chins Henning will introduce himself in a moment. He leads the research in the Transportation Research Centre at the University of Auckland. And in Malaysia, we've got Professor Ratna Muyandi, who leads the Highway and Transportation Engineering Research Centre at UPM. And then, of course, as you've been introduced to, we have Mrs. Susanna Zamataro, who's the DG, the Director General of the International Road Federation. So a very brief overview about the CRISPS project. So it's an 18-month project, and we're assessing the suitability during the project of 3 global best practice types of road surfacing. So these road surfacing types have been, or are a result of many years of research in New Zealand and Malaysia. Dr. Henning and Dr. Ratna will describe, Professor Ratna will describe those to you shortly. So these pavement surfacings have been utilized and developed in Malaysia and in Auckland. And the goal of this program is to assess their suitability within this project in the low-income country context. And primarily, we're looking at two things. We're looking at the resilience of the roads to climate change, and we're looking at their ability to save road user costs in the life cycle. What's the research methodology? So just a little bit of detail. We have 4 work packages. The first work package is underway, and that work package is undertaken in New Zealand and in Malaysia, and we're collecting data on the existing performance of roads using those 3 surfacing materials. The idea then is to extrapolate the performance of those roads to the conditions that we might consider in low-income countries. So there's a lot of mathematical modeling that will take place there. The second part, or work package work stream 2, is the life cycle analysis module, where we consider the deterioration models that have been developed in work package 1, and we analyze those from an economic point of view over the life cycle and in the conditions that we are going to expect to see in low-income countries. Those are conditions in terms of traffic, maintenance, and environmental issues. Work package 3 is a very interesting work package. At the University of Birmingham, we have a very large and unique, actually, nuclear accelerator, which accelerates neutrons at very high speeds, and we can use that to test the constituent properties of these materials. So very shortly, we'll be starting some experiments to categorize and to understand the material properties, the constituent properties within the road surfacings. We will then examine how we can develop local specifications for, first of all, their in-service use, and also for testing the materials when they're in situ, so to prevent anti-fraud. So it's an anti-fraud prevention. And then finally, you'll learn about, from Dr. Gatura, the constructability trials that we'll be carrying out with the 3 materials within Ethiopia. A very important aspect of our program is that we have a project steering committee, an independent committee, which is overseeing the research, and that's led by Dr. David Alabaster from NZTA, the New Zealand Transport Authority. And we also have a very important component, the last thing you hear about today is the dissemination strategy, because without good research, if we don't disseminate it, then it remains simply research. There's some just key points about the innovation that we'll be undertaking within the project. So what hasn't been done before worldwide? Well, we haven't assessed the suitability of best practice in the use of these 3 pavement surfacing materials, particularly for their application in low-income countries. We'll be developing novel models of the behavior of the 3 technologies under a variety of conditions, both currently that are in low-income countries, but also those we expect to occur in the future as a result of both climate change, but also changes in government policy, funding, and so on. Work like this is crucial in terms of determining the development of life cycle models for the technologies. And again, that's something that hasn't been undertaken before. So if you can imagine the data that we collect off of specific areas in New Zealand and Malaysia, how can we extrapolate that to the conditions, as I mentioned before, the economic, the environmental, socio-political conditions that we'll find in developing countries. 1 or 2 of those conditions might be similar, but there'll be a whole range of conditions which are not similar. So the part of the crux of the project is actually modeling and understanding how the material behaves under those conditions now and into the future. And then, of course, as I mentioned, we'll also be developing an anti-fraud mechanism through work with nuclear physics to see how we can develop or how we can specify a cheap, low-cost solution for doing something similar in the field. There'll be a series of field trials which Dr. Gatura will explain shortly. Thank you.
Perfect. Thank you very much, Michael. And apologies, I just realized before my microphone was muted. So thank you, Bernard, as well. I'll pass the floor now to Professor Henning to tell us a little bit more on data deterioration modeling. And then we'll, after that, we'll take Professor Ratner, who will give us a little bit more details. You're ready to go? Perfect. Floor is yours, Professor Henning.
Thank you very much. I just want to acknowledge my colleagues here from New Zealand. It's already been mentioned that David Alabaster from our New Zealand Transport Agency, he has led much of the work that I will be talking about in the development of the epoxy asphalt technology and also the epoxy chip seals in New Zealand. And then also my colleague from the University of Auckland, Associate Professor Joseph Costello, who's actually one of the students from Birmingham, and I guess in a roundabout way was the catalyst for the relationship between us and Birmingham. So the University of Auckland is central to the city of Auckland itself. Now, those of you who don't know where Auckland, New Zealand is, it's about eight movies flight distance from the UK, depending on what route you take. We've got about 30,000 students. The Faculty of Engineering is the largest faculty in the university, and then the Civil and Environmental department is the largest department within our faculty. So we draw about 200, 230 students into our Year 2 program. We're very proud. This year was announced that I think we're number 39 according to the world rankings of civil engineering departments. So the research questions, the first one, as Michael has already mentioned, has been addressed in the first part of this first stage of this project, and that was to understand the life cycle impacts of climate change on the roads. What we need to look at now is to understand the expected performance out of our alternative technology, the epoxy chip seals. And then once we know that, we need to have a life cycle analysis approach to prove when these alternative materials is going to be a better life cycle option for our roads. So the figure there shows a typical deterioration of a pavement, and when it reaches a terminal level of condition that we will intervene. Now, climate impacts will shorten the life of our pavements and surfaces, and what we try to do with this technology is to have a more resilient material that is going to then lengthen the life that we can expect out of our surfacing. For those of you who's familiar with the HDM4 model relationships, I have just drawn up the structure, what it looks like. And you can see typically that you start with your surface defects, cracking and raveling, which then can lead to potholes, rutting, deformation and roughness. So in terms of this piece of work, what we're really interested in are these surfacing defects, how soon these surfaces will crack, how long it will take for them to ravel. And then the other one that we're also quite interested in is the texture loss or flushing, which is not part of the pavement models, but certainly an important surfacing model to monitor. So when we look at the different impacts from climate change on our road surfaces, in the first instance, if there's a good amount of bitumen on your road, that the road should last long, but unfortunately during extreme heat conditions, you can expect some flushing to happen where the bitumen rises to the top of the surface and you lose your friction on your surface. The other alternative is if you don't have that much bitumen within your surface and through the prolonged heat and sunshine on these road surfaces, you start losing some of the stickiness of the bitumen through oxidization, and you start losing the chips and the raveling occurs. On the other side of the climate change impacts on the things getting a little bit wet, the predominant defects that we see through that is certainly our pavements getting weaker. So increased moisture conditions will lead to a reduced pavement bearing capacity. And as a result, we will start seeing cracks occur on our surface. And then once a cracking is there, we just get more moisture going into our pavements, which then lead to accelerate the deterioration of our pavements. So what we're going to try to do, and what I've shown here, is a typical crack progression deterioration on our road surface. So there's two stages that we're quite interested in. The first one is cracking initiation. So that predicts in the mathematical way when exactly the cracks are going to start appearing, and then after that the crack is going to grow at a certain rate. Now, what we do through a calibration process is to look at your prevailing conditions, how the pavement is built and the traffic it carries, and then for that specific condition we calibrate the model that it reflects reality on that specific road link. We don't have that much data to work with because the technology that we're talking about, both porous epoxy asphalts and epoxy chip seals, are relatively new. So a lot of our data and assumptions will come from the laboratory test that's been undertaken both in Malaysia and then also New Zealand. We do have a few trial sites out that certainly will inform us with a bit more data. So on the left there, I've got some results out of the laboratory in terms of the adhesion properties of various different surfacing and bitumen types. And we can see that we get quite an advanced cohesive energy out of our epoxy mixes. On the right-hand side, we look at chip embedment or flushing that's going to occur under heat conditions. And again, with the epoxy surface, you get a very stable, stiff surface, and it does not have that wheel track rutting that you see there on the left-hand side. We've also done some early investigation on a network level using a system that's largely based on the HDM4 approach. That's the one that we use here in New Zealand. So what we have done is we've taken a sample of the network and we've looked at the failure probability of chip seals, and then also that's a blue line, and then also of chip seals under high stress conditions. What you have here on the vertical axis is the survival rate, so it's a probability of failure, and then the life that you're going to get out of it. Now, typically what you would expect is if you look at the sort of the 50th percentile, you know more or less how long those surfaces can last. And what you can see out of our epoxy surface, the cracking probability is quite lower compared to some of the other surfaces. So we do expect quite an extended life out of our epoxy surfaces. So that's what I have for this moment. So certainly for the study area, we want to provide all weather resistant surfaces for all our road users, and whatever that may be. Thank you very much.
Thank you very much, Professor Henning. And I'd like to pass the floor now to Professor Ratna, who's going to tell us a little bit more on the conditions in Malaysia and why Malaysia was also chosen for this project. Professor Ratna.
Thank you very much, Susanna.
You will be sharing your slides.
Yes, I will.
And while you do that, let me remind to all the participants to use the question and answer function in your navigation bar to put forward your questions. I'm pushing the speakers a little bit to go fast so that we have enough for discussion.
Now, do you all see my slides?
We don't see your slides yet. Please select the right screen, otherwise we can move them from here.
Yeah, I think, why don't you do that?
We have you. Yes, you can go ahead. You need to move on slideshow mode.
Now, is it on now?
Yes, it is on.
Okay.
Perfect. Thank you very much.
All right. Greetings from Malaysia to everyone. It's evening here. Okay, I'm going to talk about Fibre Mastic Asphalt, which was developed in Malaysia many years ago, and that highly relies on the biomass waste from oil palm trees. Yeah. So I would like to show some background scenario that we have in Malaysia. First of all, our climatic condition in Malaysia. Okay, we have a lot of rain. All right, which amounts to more than, I think, nearly 2,000 mm per year. And if you look at the temperature profile a little bit, on the high side, we have an average of like 32 to 33, and the lowest around 22 to 23 degrees Celsius. But again, just to remind you, this is just an average value. There are situations when where the temperature has gone up to 36 and 37 before, but we're looking at a very rational sort of figures here. So again, this puts Malaysia in a very, very bad, highly climatic, problem situations here. Okay. And another background on the traffic conditions in Malaysia, we have almost like 31.2 million registered vehicles as of 2019. And of course, that is made up of passenger cars and the commercial vehicles as always. And the total road network that we have in Malaysia, the federal and state roads amounts to almost 250,000 kilometers. And the expressways, we have about 2,000 kilometers. But it is a pretty much a challenge for the authorities and the researchers to keep up with such a huge network for a small country like Malaysia, right? And then talking about moisture, of course, with the torrential rain in Malaysia, we have problems like water table fluctuations that encroaches into lower layers of the pavement, even into the asphalt layers. That is actually a problem. And not forgetting the moisture infiltration from the rainfall through cracks, pavement, and so on. And again, I mentioned about the temperature. We do have high temperatures, and that may soften the binder. So overall, the climatic situation is posing a major sort of problem for asphalt pavements in general. Yeah. Okay, these are some of the issues splashed across the media in Malaysia. I'm sorry, this is in our own Malay language. So it all amounts to, the problems, potholes, rutting, cracking, raveling that the other speakers have been talking about. So Malaysia is no exception, but I'm quite happy that Malaysia has come a long way in improving all the roads that we have in Malaysia. This is taken some time back, so I think this problem is pretty much reduced. I'm not saying it is solved, but it is reduced. Okay, now what about this fiber mastic asphalt? Yeah, we have tried so many different materials as modifiers in asphalt binders, but this is a novel sort of a process to be able to use cellulose all palm fibers from the empty fruit bunch. Yeah? Once the fruit is taken out, we have the empty fruit bunch that goes through the steam explosion and finally processed into cellulose fiber of certain sizes. Not all fibers will work. You may ask me whether the tree trunk, fibers from the tree trunk and the leaves work. It won't, and we have already done that. So it is from the empty fruit bunch. So again, like I said, it comes down to all the processing, the size, and so on, to be converted into pellet form. Yeah, you can see the pellets for easy introduction into the pulp mill during the mixing. Yeah. Now, how it works actually, right? Based on all the work done in Malaysia and the trial lays and projects undertaken in Malaysia on the fiber mastic asphalt, we find that the binder is retained for over a long period of time. This is the key factor in the use of this biomass waste in asphalt mixes. Yeah. All right, these are some of the promotional sort of videos, dealing with fiber mastic asphalt in Malaysia. Some of the work done in Malaysia since 2000 trial. The first trial was done in year 2000 with the help of the Public Works Department. All right, this was done somewhere in the east coast of Peninsula Malaysia. And since then, we still have a lot of data from these segments, right? And some work done in Putrajaya, all right, way back in 2000 also. And these are more recent works. 2018, they had some trial on the Senai Desaru Expressway. Now, this stretch is quite bad, after they have tried with, various technologies and so on. Finally, the fiber mastic asphalt used in on that stretch for some length, and it is still performing very well. And these are some other, road stretches that were carried out way back in 2016. It's already almost 4 or 5 years now. If we look into the micro texture, the pavement itself, we find that the binder is still retained. That is the magic thing about this fiber, retaining the binder for a long period of time. This is another 2 projects carried out in Malacca. All right, this is not a heavily loaded road, but a medium traffic road for the community there. 2 projects done in 2016 and still doing very well. And again, I would like to highlight that binder retention is excellent. All right. Okay, now with all of this, and we would like to carry out the life cycle analysis on data that is available to us, and of course we will continue to acquire more data. Basically, we will look into the traffic progression since the FMA was introduced on certain segments, and then we will look into the performance data of FMA, and at the same time we do have falling weight deflectometer data on pavements with the technology. So that should be able to give us the status of the lower layers in terms of the structural number, the E values, and so on. And with all of this data that we have, we should be able to run initial and remaining life assessment of fiber mastic asphalt, right, based on some transfer functions. If HDM is available, then we'll use the HDM4 model. Otherwise, we will develop our own regression model, which shouldn't be a problem. And but the next challenge will be to be able to tailor the fiber mastic asphalt used in Malaysia in Ethiopia with the different climatic conditions and so on. But then after looking at the Ethiopian climatic situation there. Now, if I may say this, Kola and Berha, these are the those regions around this central part here, and the temperature profile is quite similar to Malaysia. So I don't see much of a difference there, except that the rainfall range is much lower compared to Malaysia. So I'm not sure. I haven't looked at the data from there yet. So it's very difficult to say how much moisture damage has taken place there. So, but as far as the temperature is concerned, yes, it is quite similar to Malaysia. Okay, these are some of the trials still ongoing with the airport and more expressways, and I think I'm still within the 5 or 6 minutes. And
already, so I would be grateful if you can wrap it up. Thank you.
Okay, this is our state-of-the-art equipment in the lab. These are some of the equipment we have. We can run the actual photo test with the UPM developed equipment there, which fulfills the standards too. Okay, and at last, this is the oil palm fruit that is taken out. Once that is taken out, the empty fruit parts will be left over as the waste, and that's where we get the fiber from. Oh, in Ethiopia, I have noticed that I went to the internet and found that they have a lot of sizzle ham there, so it shouldn't be a problem in utilizing that. And neighboring countries like Nigeria and Congo, they do have oil palm plantation. So I think that's all for now, I suppose. Thank you very much.
Thank you very much, Professor Ratna, and I'm sorry for being the cop in the room, but I see a number of interesting questions now piling up in the question and answer section. So I just want to make sure that we respond to these people.
Sure.
I'm going to pass. Thank you.
Stop the slides.
Can you please, yes, stop sharing your screen and close your microphone?
Okay.
While I'll pass the floor to Dr. Gurmal, who's going to tell us a little bit more about the field trials, in fact.
Okay, thank you. I'll just share the slides.
Perfect. We see you well. Go ahead.
Okay, thank you. Okay, hello everyone. You've heard a lot about the project. You've seen through my colleagues' presentations, Dr. Henning and Dr. Ratnasamy about the Professor Ratnasamy about the technologies. So I'm now going to speak to you about the constructability trials we intend to carry out. Okay, so this is the outline scheme for the project, which Dr. Burrow spoke about, and I'm going to concentrate on work stream 4. These trials will be carried out in Ethiopia. We have good links with the Ethiopian Road Authority, and we have a number of PhD students working in the country, and we're going to use the PhD students to support part of this project. So the aim of this work stream is to prove constructability of technologies. As you've heard, these technologies have been trialed in New Zealand and in Malaysia, and we now need to try to see if they work elsewhere. Okay, the 3 technologies are modified epoxy chip seals, modified epoxy asphalt surfaces, and fibre mastic asphalt. Okay, so before we go into selecting the sites, we need to look at construction details, drainage conditions, properties of materials which are being used in existing roads, performance of existing surfaces, climatic conditions, things like rainfall, temperature, groundwater variations. All these things that affect the behavior of the road. And clearly we want to know about the loading conditions and how the roads have failed if they have failed. So all this information we need from existing trials, what people have done, what sort of things have been discovered, the type of soils they've constructed the roads in, the type of materials they have used in. And we will then identify some sites in Ethiopia. Okay, what we also want to do is monitor local rainfall and temperature and drainage conditions. This is very important because what we come out at the end has to be very rigorous. We don't want to just build a trial and say, okay, it's buildable. This is going to be part of ongoing research in Ethiopia, and it's going to be part of PhDs, not 1, 2 PhDs, and we need to show everything is rigorous and we fully understand the reasons why things have not worked, why they have not worked, and try to put an envelope on conditions under which these technologies work. So we intend to develop or use some techniques for measuring moisture changes within pavement layers, temperature changes within pavement layers, and assess effectiveness of drainage. We have done this sort of work in Ghana already through another research project. So it's just transferring know-how from one place to another. And of course, our colleagues in New Zealand and Malaysia have also been doing some work. So the idea is to pull all this together. So what our colleagues have done is very, very important, because we want to map what they've done onto local conditions in Ethiopia, and then we go ahead and select our sites. So in terms of construction, the aim is to monitor ease and effectiveness of the technologies, but as I have mentioned, we intend to go beyond just construction. Okay, so after construction, we will carry on monitoring the rainfall, moisture content, and temperatures, moisture content changes within the layers, temperature changes within the layers, and carry on monitoring the effectiveness of drainage. Drainage is very, very important. Water is very important. Temperatures are very important. And my colleagues in earlier presentations have mentioned all these things. Okay, we will also carry on monitoring traffic and road conditions. So the Professor Ratna spoke a little bit about selecting the site, and he put up a slide about the climate zones. It's very important that we do the trials in climatic zones which reflect not only which reflect things which are similar to those in Malaysia, so we can do a comparison of constructability, but also in a climatic zone which is very different from that in Malaysia. So, and there are places we can trial, and we're in discussions with our colleagues in Ethiopia to discuss that. So the program is that by about mid-January, we'll have developed site selection criteria, sorry about the typo there, and identify potential sites. We will then do some feet on the ground type of work and identify more details about the sites, and to home in on candidate sites, start collecting pre-construction data, do some condition monitoring, and firm up on our trial sites with a view to constructing the trials in December to February, December this year, February next year, and then we'll be launching into post-construction monitoring. Okay, I will stop there. Thank you.
Thank you very much, Dr. Gurmel. And I'm checking our time. We have 10 minutes left, and I believe it's my time to tell you quickly a few things about dissemination. Let me find it here. I hope you can see my screen correctly. Yes. Very quickly, because some of you have been asking either in the chat already and in the Q&A section. First of all, we've pulled together a project website. The address is given in the slide, and I'll repeat it here. We'll be sharing with you both the recording of this webinar and all the presentations. We have your data as well because you registered for this webinar. So as soon as the proceedings will be available, we will be sharing all those directly via email. So you'll be notified by email when the proceedings are available and where to find them. So watch out for this space for the project website. It's a subdomain within the University of Birmingham, because we will be start filling it in with resources as the project moves forward. Another important point, we have created a LinkedIn group for this project. And that answers also one of the questions that I see being posted. How do we get involved? How do we engage? Please make sure that you join the LinkedIn group, because the idea is to really build a community of practices and to use that space to not only exchange on the project and the trials and the research as it moves forward, but hopefully grow it and in a way that it stays even once the project is over. Michael has mentioned it as well, that this is just the very first webinar that kicks off the project, but there will be other webinars coming up, updating you on the different part of the research being conducted. We as IRF, and I haven't had time to make that introduction, we have been working with the University of Birmingham for several decades, I would say now. We worked together during for the Senior Road Executive course, and a lot of the CPD courses run by the University of Birmingham. And so we were very pleased to join hands and support this project, putting at the network of IRF at disposal for disseminating the research that this project will conduct. I will stop it here, and I want to make sure that we answer some of the questions. Michael, I will ask you also to help me out with that. I'll stop sharing my screen. Oops, I'll stop sharing my screen. Yes, so that we can see all of us. And I would like, first of all, to respond. Let me see this. We had the chairman of the one of the technical committees, TC41, Margot Brisink from the PIARC, the technical committee 4.1 on pavements. Margot is telling us that they're writing a report on resilient pavement, and so indeed, he would like to share the presentation. Please do that, because that's exactly what we want. We want to make sure, as I just mentioned, that we create a solid group of people and from all over the world to share and to talk to. Mark is also flagging out that PIARC will be hosting his Winter Congress in February 2022, and the call for abstracts is still open. So we are still, and all of you who are interested can still submit an abstract. We're mentioning this here, it's because the Congress will have a focus as well on resilient infrastructure. So Michael will make sure that this CRISPS project is also staged in there. A number of very interesting questions. I will start from the top. Matthew Webster is asking whether these 3 road surface technologies reduce particulate matters from vehicle tires compared to other options. He's not addressing the question to any specific speaker. I'll read the second one while you agree between yourself who has to answer. There was another question directed to Professor Ratna asking, can we use any other type of fiber? Can we use to retain binder instead of palm? So I'll start with these first 2 questions. Professor Ratna, would you like to respond?
Yeah, the second one, all right, on the fiber. Yeah, sure. Thank you very much. Yeah, thank you very much for the question. There are so many fibers available, but then, like I mentioned in my slides and presentation earlier, there are specific characteristics required of the cellulose fibers. You may ask me whether fibers from the tree trunk, the leaf, will be suitable for use in asphalt mixtures. I said no, because there are several techniques involved in their characterization and selection of the fiber. And of course, that went through a lot of study, research over the last 15 to 20 years. So it goes through a very microscopic kind of work. Yeah? So like I said, only certain type of fibers are potential for use in asphalt mixtures, not all fibers. Of course, you may get cellulose fibers from other sources, but you need to study and look at the characteristics that will warrant the use of it in asphalt.
Thank you, Professor Ratna. Anyone who wants to answer to the question about the whether the 3 road surface technologies reduce PMs from vehicle tires compared to other options, or we can respond that question bilaterally. Michael, you tell me.
Yeah, so at the moment, we haven't, as far as I know, no studies have been done in that area. It's a very interesting, very good question, but it's something that we can look at in the project. So it actually gets my thinking hat on immediately. And there are a number of ways that we can do that, obviously through laboratory experimentation, but we can also look at it actually from a theoretical point of view, because once we understand the performance modeling through the HTM4 relationships, we can start to understand emissions and emission scenarios. So that's something that we can undertake. But it's a very, very good question.
Yeah, thank you, Michael. There are a couple of people asking as well on how to get involved, and I just mentioned in my final slide. So make sure that you link up with us in the LinkedIn group, and that will automatically prompt you in this core group of people. So we are creating a community of practices for the project. And so all your inputs and questions and the exchanges we'll have with you will be extremely important, not only to disseminate the product, but also to learn and get different perspectives on the things that are being investigated. I have another very interesting question. Actually, I saw that Professor Henning has responded in the Q&A section, but I just want to make sure that everybody sees that and hears that. Margot is asking, will the economical aspect be addressed with the life cycle costing assessments since the exposed binder is slightly more expensive than traditional bitumen? Theos, would you like to answer that?
Absolutely, yes. The whole objective here is to do the life cycle analysis to determine whether the initial increased cost is going to be saved over the life that you expect these surface types to last a little bit longer. So your maintenance and the renewal costs will come down, your life cycle cost. So that's absolutely, I'll take the next one also, the question.
So, yeah, sorry, can I just interrupt there, Tuns, if you don't mind as well, just to add to your response. So obviously in the life cycle analysis, the other important thing is to consider not just road agency costs, but road use costs.
Yes, absolutely.
So we're, you know, balancing possibly a more expensive treatment to start with compared to downstream savings, yes, in maintenance, but probably equally importantly, if not much more importantly, are the savings that occur to the road user and indeed into the environment. So that's something also that we'll consider in life cycle analysis. That's part or work package 3. And the other thing within work package 3, we'll be looking at scenarios which are associated with the do minimum strategy of don't do any maintenance. And again, how will these roads perform under those conditions? Because we all know with the best intentions in the world, maintenance is not always carried out. Sorry to interrupt you, Tun. So
perfect, thank you.
Okay, 9:58. I'm conscious of time. Thank you very much, Professor Henning. And I'm running through more questions coming in. And please, if we do not manage, because probably we won't have time to respond to all the questions, make sure you just use the LinkedIn group, connect with us and post those questions in there so that we can keep going this conversation far beyond this webinar. There's another question from Chris Rust, who's asking, are you considering full-scale accelerated pavement testing, APT, to evaluate the performance of this new surfacing? That's a technical one.
Dr. Henning or Professor Ratner will be able to answer that one.
Yeah, so in terms of, we have got an accelerated pavement testing facility in New Zealand. It's called Captive. And we have completed some accelerated tests on epoxy porous asphalt surfaces. We have not done that on the chip seal equivalent yet.
Okay, on my part here, we have this accelerated loading facility that I showed in my slide, which is called the, it is actually an in-house equipment developed almost 15 years ago, that is able to provide up to easily 25 bars and actual tires, and you know, it is called the rotary wheel, rotary compactor and wheel tracking device. So that should be able to give a prototype, you know, type of test. So yes, it will be carried out. And in fact, some work has been carried out before too on May.
Thank you very much. I'm just trying to scroll all this, and probably will take, it's 10 o'clock already. Apologies. So we'll take one final last question. And again, I'll ask those of you who have put forward questions and we have not addressed them to make sure you connect to the LinkedIn group. Can I ask my team as well to post in the chat the link to the LinkedIn group? We'll be sharing it, of course, via email and via the slides, but maybe Maris or Melin who are on the line, if you can post the LinkedIn tag directly in the chat, people can be immediately redirected. I'm just going to take one final question here from Andrew Otto that says, how will long-term data be collected and shared, given that the project itself may not be longer than 4 years?
Dr. Gatora, I think that's a question for you with the performance monitoring and the error.
Thank you, Dr. Burrow. The project itself is going to last for 18 months, but we have a number of students who will be working on this project beyond the end of the project, and they will carry on for about 4 years. Now, it's also important to note that these students are based in ERA, and ERA has already expressed to us that this technology is of a great interest to them, and they will carry on, continue to monitor it, and it will no doubt at some stage become part of their standards if everything goes well, and there's no reason to believe otherwise. So the project will carry on beyond the 4 years, but how long it carries on for depends on ERA. And I think I better stop there because our students will finish their PhDs in about 3 years' time, and then it's for ERA to carry on with the ongoing work. but we know they are interested in, very, very interested in these technologies, and they want to use that to prolong the life of their roads.
Thank you very much, Dr. Gurmo. Michael, I'm in your hands. It's 10:02. Should we wrap it up here? And I would encourage all the people to again join us via the LinkedIn group, because that's where we can keep this conversation going. My team, as I've seen, has posted in the chat the links, so make sure you connect with us. With that, I think I can close this meeting. Michael, I don't see you. I don't see in the video anymore. I hope you're still with us. Let me thank all the speakers who have been with us this morning, presenting us this exciting project, of which we are extremely happy to be part of. And let me thank all of you, the participants who have joined us this morning, and for the interaction we have had with you. We are recording as well your questions, so we'll make sure that you get answers if we were not able to answer all your points right here. I just wish you a very good evening for some of you, Professor Ratna, probably night, a good afternoon, a good morning to all of you. Thank you very much.
Thank you.
Thank you.